Hello everyone, welcome to my channel. I'm Aditi Kumar, and today there is a very special topic I wanted to discuss. So this topic is basically it's based on mathematics. So it's basically the area of the mathematics. So every day we are talking about math, right? Or every day we are basically, I can say every day we are using the math, right? So if you are sitting here, if you are talking, and if you are standing, there is a mathematical equation behind it. So the point here, we are talking about different type of mathematics. For example, this calculation is required. So that is the probability that rain will happen, right? Or maybe I can say this is the optimal solution, but we don't know the entire picture of the mathematics. So where actually this optimization is coming, which category basically the that numerical computation or maybe that calculation is coming. That's why I thought this video actually I will start from a big picture of the mathematics. So it will give you a very big picture and a very brief idea about the classification of the mathematical field, so that going further, if we can dig dive into each area, and maybe you can understand the in-depth further classification under a specific area. But today's session is basically to give you a complete picture of the mathematics. It's a big picture. So I renamed this particular session as a mathematics. There is a big picture. So I wanted a breakdown of the major branches and subfields of the mathematics, and also I highlighted what is the ideal or maybe the practical application of this particular uh, part of this mathematics, or basically the subfield of the mathematics. So let's start. So just the first slide here, so which basically I have taken each and every category into the consideration, and I further classified the high level division of the mathematics is this 5 category. So the first category is the pure mathematics, and the second category is your applied mathematics. So third category is basically the discrete mathematics. Fourth category is computational mathematics, and the and the last category is interdisciplinary mathematics. So if I'm talking about pure mathematics, there are certain major areas basically, or major subfields are coming under pure mathematics. So pure means I can say it's basically the foundation of some mathematics, right? So here I can see here there are 7-8 categories, actually major categories I highlighted here. So first one is basically algebra, analysis, it's geometry, topology, number theory, logic and set theory, and combinatorics, right? So basically in our school days, we basically use that particular mathematics. For example, algebra, right? Geometry. So number theory, set theory is a very popular subject in our school days. But here actually we need to understand, at least we need to highlight some application of this particular categories where actually it is getting used. But maybe in the next further classes or further videos, basically I will try my best to just further classify and get a detailed picture behind each category. So I'm starting digging dive into the pure mathematical category, major categories. So starting from algebra. So algebra basically the major four areas, major four type of algebras basically is the elementary algebra, abstract algebra, linear algebra, and Boolean algebra. So if I'm talking about elementary algebra, so it's basically is a basic arithmetic and problem solving, right? Like summation, addition, subtraction, multiplication, square. These are basically the elementary algebras, right? So this is basically coming under whatever day to day we are using, right? So calculation, summing, subtraction, multiplication, right? So it is coming under like that's the elementary algebra. Then the upper step is basically the algebra. Then the further upper step is basically the pure mathematics. Then it is the parent of mathematics, right? So mathematics, pure mathematics, algebra, and elementary algebra. So this is how actually it is classified. And next the topic is basically abstract algebra. So it's basically the different special region or special applications it is getting used. So there are further major three areas or major three fields here: the group theory, ring theory, and the field theory. So especially the quantum mechanics and physics is the major applications, special geometry and major applications actually is specific to this category. So for example, group theory is basically essential for transformations, symmetry, and your ring category is for algebraic geometry, and field category is specifically for physics and quantum mechanics. So it is basically the ideal in their own area. So it is the ideal use cases in their respective area. So linear algebra, which is a very popular in the field of data science and artificial intelligence, especially in the vector space. So linear algebra plays a very vital role in data analytics, physics, and computer graphics. So linear algebra is basically it's a very major area where it is getting used in the computer science. Basically, the computer science scientists, they always use linear algebra, core linear algebra to design the computer system, and basically I can say optimize the system, right? So the last category is basically the Boolean algebra. So again, this is the vital application in the computer science and the electronics devices. So the digital circuit design, everything basically the based on Boolean algebra. So let's go to the next session here, the analysis. So analysis is basically the second category of the pure mathematics. So here the real analysis, the foundation of the calculus and essential for physics and engineering. So we always talking about derivative integrations, right? It is coming under this category actually. The complex analysis, the fluid dynamics and quantum mechanics are the field where it is getting used richly. And the functional analysis, again the quantum mechanics and signal processing and optimization. So basically today the IoT is a very popular thing, right? So we are getting the data from different sensors through IoT, right? So they are basically functional analysis, the core concept or core foundations of the mathematics is getting implemented behind each and every algorithm or tool. So the next category is geometry. Geometry is basically the child items here is basically the Euclidean geometry and non-Euclidean geometry, differential geometry, and algebraic geometry. So these are the four categories. Basically, Euclidean geometry is basically fundamental of the architecture of the design, and non-Euclidean is basically applied for physics and especially for general relativity. So differential geometry here, the crucial physics and basically the computer graphics and robotics, it is getting used differential geometry. So the algebraic geometry is basically the major application here is in cryptography and coding theory. Basically, I can say the encryption, this type of techniques basically is richly used algebraic geometry. So topology is a branch of pure mathematics. So here basically the two type of topology I highlighted here. So point set topology and algebraic topology. So the major area where actually this is getting implemented is the data analysis and machine learning, especially in the data area of the data science. The topology is the mostly used in the, I can say, the backbone of the core concept or core logic. The number theory basically the arithmetic, algebraic number theory, and analytic number theory. There are the three type of number theory I highlighted here. So used for cryptography, again the arithmetic in the coding theory, it is arithmetic is also a use cases there. So arithmetic basically is getting used there richly. So algebraic number theory applied to cryptography and coding theory. Basically the number theory, so basically always implemented in the field of cryptography, and basically to get a unique encryption technique, right? So this type of technique basically is based on number theory only. So coming to next item of the pure mathematics, so logic and set theory, right? So logic and set theory basically the proportional and the predictive logic essential in the computer science. So proportional and predictive logic is basically a I can say the essential of, basically it is very core concept of the programming. When actually we are talking about programming, then every time we will always talking about logic, right? In my first introductory section also I mentioned there is a point we should think logically, we should think in the appropriate way to solve a program. So whether it is a programming or any concept, basically logic is very important, and this is basically the concept derived from our core mathematics. And the model theory, basically they applied in computer science, popular in database. So modeling is basically a systematic approach of organizing the thing, right? So that is known as modeling. But again, this is the very interesting point here is it is getting derived from mathematics. So set theory, the foundation of mathematics in the logic and computer science. So this is basically the set theory is basically used there. So set theory is, I can say, is the heart of behind the statistics and the probability also. Set theory is the core concept. So that actually we are basically just, I can say, grouping into different categories, and then actually we are doing the analysis. So it is basically the major point in the field of data science and analytics. So behind the logic or different models, so set theory is the backbone. So these are basically this is, I think, is the last one, combinatory. So combinatory is basically your basically number of, I can say, especially combinatory is, I can say, number of combinations, right? Permutation and combination, the concept actually we had about that earlier. So it is basically used in multiple cases actually. For example, I can say graph theory. In the graph theory, basically it's the core concept of our social network, right? So there in the computer network and network analysis, the optimization. So graph theory basically is used. So in order to be combinatorial is used in counting, problem solving, and scheduling and optimizing. So these are also the major application areas of combinatories. And the combinatorial geometry is basically applied in the computer graphics and or designing and optimization. So major point here I can derive from combinatory is basically it is getting used majorly for optimization and also in the network analysis, which is the it is richly used in the network analysis concept. So second category is our applied mathematics. So these are the category we covered till now. It's the pure mathematics, and these are the foundations of mathematics, I would say, because based on that our applied mathematics is basically created, because the pure mathematics is basically our base mathematics, fundamental mathematics. On the top of that, there are multiple applications of the mathematics is derived, so that it is basically I can say the heart or backbone of the mathematics, right? So then maybe let's proceed for applied mathematics. So applied mathematics, it means, so top of the pure mathematics, so whatever the major areas or maybe specific to use cases we are deriving, or maybe we are preparing the tool or maybe further concepts by using the pure mathematics, so that it will be used in the special area, in the special use cases. For example, you can see here multiple categories here. Differential equations. So differential equations basically one applied mathematics. So then maybe statistics and probability, which is basically very popular concept and basically very essential concept for our field of data science. The third one is the optimization, numerical analysis, mathematical physics, and mathematical biology. So operations research. So major, I highlighted mathematical physics and biology only, but there are some other areas are, but I highlighted here the major areas under applied mathematics. So let's go through one by one and dig dive into the different categories of applied mathematics, and it's a we will look into that how it is getting used in the real scenario. If I'm talking about differential equation, there are two types of equation. So ordinary differential equation and the partial differential equation. So the major area here basically is I can say the differential equation is in engineering, economics, and physics. So engineering is the major application of differential equation. So whether it is a ordinary differential equation, the partial differential, there is a little bit of a difference between ordinary differential equation and partial differential equation, because in the second case maybe something actually we are putting independent, but again the same use cases actually it is getting used and depends upon the scenario. Then the second category here is statistics and probability. So under the statistical probability, I only highlighted the major points here, the two types of statistics, descriptive statistics and the inferential statistics, and second last one is basically the probability theory. So this is descriptive statistics is basically, I can say, is the summarization of the data to what summary you are getting, whatever the data is existing, right? When the inferential statistics basically by taking the inbuilt data, whatever the data in our hand, how we look future, how we derive the future from the data in our hand. So this is basically the inferential data. So definitely we will have a very I can say descriptive or completely comprehensive playlist related to the statistics and the probability, because this is the heart of the data science, and without statistics we cannot proceed for data science or machine learning or any modeling technique in data science or maybe computation of the data. So last one is the probability theory. So probability theory basically a very major area. I can say this is again without probability statistics is not possible. So the thing is basically the major application area here is the machine learning and the statistics, I can say, because whether this is a statistical learning or machine learning, so behind that probability plays a very major role. Again, the core is the probability. It's the very interesting area among our applied mathematics, so which plays a very vital role in the data computation, especially data analytics. So optimization, it is basically the two categories basically I highlighted here. It's linear programming and non-linear optimization. So it's the basically I highlighted here only basically in a high level I highlighted here. So in the resource allocation, production planning, logistics. So each and every steps basically we need optimization. For example, we need to deliver one material from this place to this place. So there are 10 ways we can go from this place to another place. What will be the optimal solution? What will be the optimal way we can proceed so that our fuel, we can actually save our fuel, save our time, right? So again, it is directly proportional to the price of a company. Price, definitely we will save the price. That's why optimization plays a very important role in each basically scenario. Again, in the each area or maybe each domain, there will be an optimal situation, right? For example, a situation, a problem we are going to solve, right? There will be optimal solution which can be a best way to solve this particular problem, right? Again, this the interesting point is the concept is getting derived from our mathematics, right? So that's why the mathematics is the backbone of everything. So coming to non-linear optimization, it's basically the application is engineering, machine learning, so economics. So these are the major areas, because again, this is non-linear optimization is a very high level term. So we will definitely for optimization, I will try my best to just create a complete playlist so that it will cover different type of optimization and its use cases and what will be the ideal use cases each and every model, because it plays a differently in different scenario, right? So there are multiple types of optimization technique. So it's not non-linear optimization and linear programming is basically a high level term. Under there are different type or different flavor of the optimization techniques. So definitely we will cover, but again, this is the high level overview of the mathematics. Let's go for different next session. Then next item is basically numerical analysis. So the numerical analysis basically is a also a major area in case of basically I can say computer simulation and computer graphics. So numerical linear algebra, numerical integrations, and it's a numerical solutions of ODE and PD. ODE is ordinary differential equation and partial differential equation. So the major use cases here is in engineering. So basically the computer graphics in physics. So definitely we will cover in detail in our further videos. So coming to next, and it's mathematical physics. It's basically I can say how mathematics is getting used in case of physics. For example, classical mechanics, quantum mechanics and quantum now today world basically the quantum AI is the very popular. Actually, this is a future of AI, maybe I can say. So that actual quantum physics is the core of that, and again this is a applied of our core mathematics. So everything is basically derived from mathematics. So coming to next, the mathematical biology. So mathematical biology basically is basically specific to our medical or biology area. So it's a population dynamics, and it's basically mathematical ecology. Then epidemiology. So basically the study of spread of diseases within the population. Again, this is specific to, there are certain flavors of the mathematics, which is basically mathematical biology, which is the top of our pure mathematics, and this is dedicated for our healthcare industry, or maybe I can say medical purpose. Yeah. Then OR is basically the operational research is basically also a major area in case of maybe I can say the special use cases is for decision making. So decision theory, is a very important area in data science also, because again, for example, as a business company head actually want, because you are working as a data scientist, for example, and company head wants you to just give a proper approach to take decision further. For example, we are going to launching a product, so whether we should launch into in that particular country or not, so how we will do the analysis, we will take the data and do the analysis, and again it will be a decision theory behind your model, or it will be working to identify this is basically the decision you should take, you will basically the suggest to your company head. So again, the game theory is the basically the I can say the economics, political science, and biology is basically the in the very application area where the game theory is getting used. And coding is basically in the applied in the telecommunication, and traffic engineering, and computer systems. So these are basically the areas of operational research is basically plays a vital role in different, almost in the different sector, because each and every sector needs a proper decision, right, to proceed ahead. Otherwise, basically, if you will not use this basically mathematical technique, then we should not take, we cannot take a basically the good decision, right, correct decision, optimal decision. So we take a optimal decision, and decision plus optimal. In the optimal, this is you're basically actually your optimization and decision means of operational research, because everything is basically interrelated. So the third category we covered till now is basically the pure mathematics or applied mathematics. Then third category is basically the discrete mathematics. So the discrete mathematics is basically, I can say, it's basically a very major area in case of data science also. So here major points here is the graph theory, your combinatories, and coding theory, cryptology. So graph theory and combinatories, again it was they are actually our pure mathematics. So but here is again in the discrete mathematics, because it is basically it is a core mathematical concept and directly used in the as a discrete mathematics. So that's why I put explicitly here these two category under pure mathematics and discrete mathematics. Let's cover one by one in detail how it is getting used in the real world. Again, though, for graph theory, I quite highlighted different thing here, network flow, color. I gave some different example here. So there are basic, again, the concept is same. It's basically the core use cases is the social media and the network, right? So in the computer network also, in our social media also, the concept is same, networking, right? So the graph theory is a very major, basically the, I can say the tool which is getting used there, because this is the graph theory is the backbone for our social media and our computer networking system. The algorithm is basically the graph theory. Then combinator is the same. Basically, we are some theory actually I highlighted here. So Ramsey theory and external combinatory. So combinatorial design. So these are basically some more points so related to combinatory. But again, this is basically the same use cases. So we need a combination and a permutation, right? So what are the effective way we can do that? So what are the studies, the occurrence of the order in disorder? So these are the basically the major, because otherwise, for example, I'm giving, we are just playing different games. So how many will be the number of combinations from this particular group, right? So in that case, if you will not have a proper mathematical concept, then we cannot derive that easily, right? So that's why combinatory is basically for counting. I can say counting. If you are talking about counting, then we should think about combinatory is the core concept of that. So the coding theory basically here is basically, I can say I can say it's basically how we will code the system a particular data, right? So error correcting code, then information theory, the data in case of data transmission and storage. So we cannot store the data directly, right? Whether it is a database, so whether it is a maybe I can say, think about computer, right? How it is working. It always understand 0 and 1 binary. It's not 0 1. It is basically a false, high or low. So then we are representing into the digital system 0 and 1. That's why on the top of that there are multiple type of mathematical number system, right? Hexadecimal, decimal, your octal, right? So but this type of encoding technique, so coding theory is basically the backbone of that. So that in the whenever actually computer is performing the task internally, basically it is encoding to a particular format so that computer can understand. Again, the microcontroller behind our computer or any controller system, they can understand. The cryptology basically especially for cryptography, cryptanalysis, and basically the curve, elliptic curve cryptography. So these are basically the three categories of cryptology. Cryptology basically is, I can say, a secure encryption technique, right? How can I can say the cryptography is basically the decentralized system. We will encode it the decentralized system so that everything will be transparent, I can say. So these are the major areas, especially this category of the discrete mathematics cryptology is dedicated for cryptography. And the fourth category basically is the computational mathematics. So computational mathematics means, if you know what derives here, the computation means the more processing, right? Some high level of processing. So also I can say on the top of applied mathematics, these are the areas, or maybe I can say categories of mathematics derived. So if you can say like that, or pure mathematics on the top of that, our applied mathematics, then also applied mathematics and our discrete mathematics, that both from the both basically the computational mathematics is getting derived, because we are using um, some core concept of the mathematics and the derived concept of the mathematics into some uh, beautiful tool, so that actually it will be directly used by the scientists and the engineers in the field in the real application. So algorithm complexity theory and computer algebra and numerical simulation, these are the four major categories I highlighted here in the under the computational mathematics. Then if we are talking about algorithm, then again complexity theory and a randomized algorithm, then everyone is talking about algorithm, right? So this is basically the flow of how we are thinking, right? Algorithm is the same. So studies of efficiency of the algorithm, complexity theory, right? So, and we heard about that though. Basically the notations actually we are using to measure the efficiency of the algorithm, right? So then again the this type of thing, a complexity theory and randomized algorithm, basically the techniques actually used for that is the randomness of the algorithm design. So these are the core concept where basically of the algorithm we are basically using the different respective areas. Then the computer algebra, it's basically the symbolic computation and the algebraic manipulation. These are the two categories, basically the manipulation mathematically, exponential, symbolically. So because basically I can say whenever we are converting a particular mathematical expression into a symbol, there is an encoding technique that computer algebra so basically plays a very vital role. Basically it is used for computer system design. So this type of thing. And algebra and basic algebra and computer algorithm is computer algebra and especially algebra algorithm. There are two areas basically richly used for computer design. The numerical simulation, the simulation, if you are talking about simulation, then again it's specifically to applied statistics area in the modern probability stage. So simulation is a very vital area in the model probability, where a Monte Carlo simulation and a finite eliminator method is the basically specific to engineering and structural analysis, but especially Monte Carlo simulation is basically for statistical modeling and risk analysis. So this is very major area in the field of probability in statistics, even in the data science, because behind the whatever the model we are ready-madely we are using from using any library in the data science or machine learning, but the core concept is that if you will just dig dive into that algorithm, how it is getting built, so by this particular provider or maybe the company that tool build, so we will basically get at the end these concepts are basically getting used there. So that probability and the simulation technique and statistics. So the last category, major high level category here is the interdisciplinary mathematics. So interdisciplinary mathematics, why I am highlighted here. So we highlighted two categories, mathematical physics and mathematical biology under applied mathematics. So here there are some areas of mathematics where some techniques is specially dedicated to for that area. For example, economics, right, sociology, psychology, and medicine. There are four major categories I highlighted here. It is basically some tools specially it is designed in mathematics specific to this area, and this is I can say that the blessings of the mathematics to that respective area. And my next actually I will maybe just summarize whatever the four categories. So the mathematical economics is basically the game theory in economics and the financial mathematics. So financial mathematics is a very I can say deep concept or very major concept in the financial area to take major decisions in the financial engineering. The financial mathematics plays a very major role. So pricing, derivative, risk management, and portfolio optimization is a I can say the topmost concept in the financial market. So without that, one investor, one trader cannot proceed further for a big decision or maybe some optimal decision. That's why these are the concept is very important. And mathematical sociology is basically the social network analysis and agent-based modeling. Again, the agent-based modeling basically is simulation the interaction of the agent in the social system. For example, the concept can come here in case of reinforcement learning. For think about self-driving car, they are basically the core concept is the reinforcement learning from the unknown environment. It is getting trained and taking the appropriate decision further, and gradually basically it is getting knowledges and taking the further good decision as compared to previous. So again, the concept here is agent based modeling and social network analysis, but the same concept came from the mathematical concept is mathematical sociology. So mathematical psychology, it's basically we all talking about cognitive, right? Cognitive computing, our neural network, right? So but the best concept is the mathematical psychology. So decision theory for psychology and the cognitive modeling, because again it is basically related to the human behavior, how one person is thinking, how one person is basically have the learning power. So that's cognition. It's not as the known as I can say the cognition. It is the I can say the concept is richly used in case of our neural network, which is the I can say that the very important tool for deep learning, especially a part of machine learning. So but the concept here is the mathematical psychology behind building the neural network. And the last concept here, the mathematical medicine. So again, biology is different and medicine is different. Here it is during our medical or maybe medicine manufacturing industry, or maybe I can say the composition of the medicine, then this is basically some biostatistics and basically epidemiological modeling, though it's basically a very major or maybe very important tool while we are composing or maybe we are deriving the formula for any medicine. So again, whatever the concept actually we covered till now, the five categories basically. So these five categories basically as the top category of the mathematics, and we covered basically the child or maybe some examples of subcategories under these five category. But again, this is basically some I can say limited examples or maybe subfields of the mathematics. But again, each category, for example, here in the first category is basically the set theory, right? Under the set theory, there might be multiple areas. So probability statistics. So there are multiple areas or multiple subfields under the probability and statistics. So definitely, I will try to build some playlist or prepare some playlist specific to some area. But again, I was thinking that to just create a playlist specific to those areas which area is basically essential for data science and machine learning. So for example, biostatistics, or maybe I can say mathematics for medicine, right? We can take it later whenever we will think about how data science is getting implemented, or maybe the application of the data science or machine learning in the field of healthcare. At that time, maybe we can create this playlist, but at least some basic concept of, for example, probability, statistics, optimization, decision theory, these are the basically linear algebra. So these are the major areas, and these are the essentials for building any data science model or machine learning model. So definitely I will start uh, just preparing the playlist respective areas, and we will dive into that how it is basically getting used in the respective field. So thank you very much for watching. So and please do subscribe my channel so that you will always get a notification while I am uploading any new video. And please feel free to put any comment so that I can basically rectify if I'm something actually I need to do further. And also I will plan according to your suggestion. If you have something in your mind, then please put it in the comment so that I can I will keep in mind while preparing the content further. So thank you.